This is going to be a video to go over the substitution method on solving systems of equations. I'm going to work out a couple of problems. I'll start with kind of some easier ones and then a couple of ones that are a little bit more challenging. So for this first one up here, solving systems, we're still looking for the ordered pair where the two lines intersect. So here are your two lines here, negative 7x minus 2y equals negative 13 and x equals 2y plus 11. So the first thing you want to think about is which one of the equations has something isolated. So in the second equation, the x is by itself, and the way this reads is x is 2y plus 11, or x and 2y plus 11 are exactly the same thing. So that means we can actually take the 2y plus 11, mark it, there we go, and plug it in for the x up here. Just make sure when you substitute, if you have a coefficient on what you're substituting into, you put parentheses around the terms that you're inputting. So instead of it going to be negative 7x minus 2y equals negative 13, it's going to be negative 7, and then in parentheses 2y plus 11. And then the rest of it, minus 2y equals negative 13. From here, you can just solve just like you normally would. Oops. It's like negative 16y minus 77 plus 77. So that's like 64. So it's negative 4. So after you solve it, that's your y value of your ordered pair. And in order to find the x value, you would just plug the negative 4 in here. So it would be 2 times y, which is negative 4. So it would be x equals 2 times negative 4 plus 11, which is 3. So there's your ordered pair. So that would be the first one. The second one that I'm going to do on this video, let me like block this so it stops coming in and out. Okay, is one where you don't have anything isolated. So in this case, we can alter one of the equations so we get a nice isolation. I can actually solve for y in the first equation pretty easy. I just got to move the 5x to the other side. So if I zero out the 5x, add 5x to both sides, I can rewrite the equation y equals 5x minus 3 or negative 3 plus 5x. Either way. So all I did here there was this. And then once you get to this step, it's exact same. Y is equal to 5x minus 3. So therefore, instead of writing y in the second equation, I can rewrite it as 5x minus 3. And then distribute. Of course, be careful, that's supposed to be a plus 24. So negative 37x plus 24. So negative 37x plus 0. So your x value is 0. And then I would actually plug this back into one of the original equations for the x value. So and then solve. You could plug it in here, but usually we just go ahead and say plug it back in the original. So it'd be negative 5 times 0 plus y equals negative 3. You can see y is just going to be negative 3. So there's your ordered pair for that one, 0, negative 3. The only other one I was going to show you was the same kind of setup, but some of those special cases, as long as I solve it right. The same thing, so look here, nothing's isolated, but I could easily isolate the y in the second equation by moving the x to the other side. So I'm going to do that, zero the x out, and then I'm going to input this for the y up here. Excuse me. So it'd be negative 3x plus 3 times x plus 3 equals 4. And then when you're solving this one, you'll notice that those are going to turn into 0. So you're left with negative 9 equals 4. For this case, it's no solution. Your lines are actually parallel to one another, so they don't have any ordered pairs in common. All right, thanks for watching.